Hello, ladies and gentlemen. Due to the current situation, it is not possible to personally guide you through the current implementation of ENVI-PUR's intensified wastewater treatment plant in the village of Horoušany. We would like to take you through a video tour of this membrane wastewater treatment plant. The wastewater treatment plant is in the village of Horoušany. It is intensified for a capacity of 2000 PE. It is situated in the same place and uses most of the tanks from the original treatment plant, which stood here and had a capacity of 1000 PE. Doubling the capacity was possible thanks to the use of membrane technology. Membrane bioreactor technology works with a higher concentration of sludge compared to conventional cleaning with settling tanks. Thanks to the use of membrane bioreactor technology, it is possible to double the cleaning capacity in the same tank volume, thanks to the higher sludge concentration. Membrane bioreactor technology is currently the most modern that can be used in municipal wastewater treatment. This technology uses membranes immersed in activated sludge instead of the standard sedimentation process in settling tanks to separate the activated sludge, which is the carrier of the biological treatment process itself. The intensification of the wastewater treatment plant lasted about 14 months. And after its completion, the municipality of Horoušany and the operator of the treatment plant have at their disposal the most modern treatment plant for municipal wastewater. Membrane technology allows all water permit limits to be safely reached with sufficient reserve. And the treated water is of such quality that if the legislation allows it, it is possible to reuse this water. For example, for the care of plant life in a village, for the cleaning of roads, and possibly, after some other treatment, more demanding applications for the reuse of the treated wastewater. The project was designed to make maximum use of the existing tanks and buildings of the original treatment plant. Closest to us in the picture are the newly built tanks of the membrane chambers where the filter membranes themselves are sunk in the sludge mixture. This is followed by the original building of biological reservoirs and mechanical pre-treatment. And at the back, with the highest gable of the roof, is the newly built sludge terminal building, which stands on a new sludge tank and a buffer tank for rainwater. All wastewater from the villages of Horoušany and Horoušanky flows down in front of the treatment plant to this pumping sump, which is equipped with a system of pumps for pumping to a part of the mechanical pre-treatment, or in case of rain, for pumping into a rain buffer tank. The pumping station is equipped with the first stage of mechanical pre-cleaning, which is a sieve basket. For better operator comfort, the handling of the sieve basket is performed using an electric lifting device. We are now in the mechanical pre-treatment machine room, which is located above the denitrification tanks. The discharge from the pumping sump, the wastewater flows to the machine-scraped sieve with 2 mm holes. This fine mechanical pre-cleaning is fitted to protect the membranes from mechanical damage or blockage. The mechanically pre-treated water then flows through a sand trap and onto the distribution object. The distribution facility is equipped with sliders with electric drives, which allows either to close the inflows to individual lines automatically from the system, in case of failure or remote operator intervention. If the capacity of the biological part of the treatment plant is full and there is still more water flowing, it is possible to discharge mechanically pre-treated water into the stream by closing both of these slides and opening the slide of the bypass of the biological part. This situation would be, for example, during torrential rain. Mechanically pre-treated water flows into two identical biological treatment lines. These are in the arrangement of D to N technology, which means nitrification with pre-denitrification. The denitrification tanks are located under the floor of the mechanical pre-treatment machinery space and the nitrification tanks in this part of the building. All biological tanks are original and preserved from the original treatment plant with half capacity. The increase in capacity is possible thanks to the higher concentration of sludge which the membrane bioreactor technology allows to use. The nitrification tanks are equipped with an aeration system by which air is supplied by blowers, which are located in the blower room. The operation of the blowers are controlled by an oxygen probe. In addition to the oxy probe, a leveling probe is located in the activation, according to which the filtration cycle is controlled. All controls are backed up in case of failure. In the event of an oxygen probe failure, the blowers are time controlled. In the event of a level measurement failure, backup floats are fitted. Two pumps are located at the end of the nitrification tanks. This is a so-called recirculation pump, which pumps the activation mixture from the end of the nitrification tank to the membrane chambers, and it is an excess sludge pump which in automatic mode pumps the excess sludge into the sludge tank. We are now at the membrane chamber. The activation mixture is pumped into the membrane chambers by recirculation pumps from the nitrification tanks. In each membrane chamber, two membrane modules with a total area of almost 2,000 square meters of filtration area are immersed. Membrane technology, as already mentioned, achieves high-quality outflow. To illustrate here, the bottle on the left is a crude feed to the treatment plant before mechanical pre-treatment. In the bottle on the right is the final drain, which flows into the drainage systems. Polymer plate membrane modules with the possibility of full backwashing are installed, and backwashing with chemical dosing. A physical backwash with purified water allows the use of high filtration performance, and thanks to chemical backwashes, it is possible to maintain these high filtration capacities in the long term without the need for manual cleaning of membranes. We are now in the machinery room, where the heart and lungs of the entire treatment plant are located. The heart are the permeate pumps. There are two, one for each line. These pumps pump purified water through the membranes. The purified water, after passing through the pump, flows into the permeate tank. The permeate tank then serves as a reservoir of purified water for backwashes or for chemical washing of membranes. Alternatively, this water can be used in the treatment plant area as technical water. The lungs of the whole system are 4 blowers. 2 supply air for the activation tanks and 2 for the membrane chambers. The 5th small blower is used to aerate the excess sludge storage tank. The blowers and their arrangement are realized so that substitutability is possible without a spare machine. Chemical management consists of 4 dosing pumps, which are linked to the permeate piping and the permeate pumping and membrane cleaning, for oxidative chemical backwashes and for acidic chemical backwashes. The membranes are cleaned by oxidative chemical rinsing with sodium hypochlorite. Thus, 2 reservoirs and 2 dosing pumps are used for dosing sodium hypochlorite, and the remaining 2 dispense citric acid during an acidic chemical backwash. We have sensors and measurements placed on the permeate pipeline, which serves as a data source for controlling the treatment plant. There is a pressure sensor, a pH probe, and flow meters. Based on the information from these sensors, the filtration and filtration cycle is controlled. There is also a compressor in the machinery space. Compressed air from the compressor is used to drive pneumatic dampers, automatic on the permeate pipeline. And there is also an automatic pressure station, which sucks purified water from the permeate tank. Water from the automatic pressure station is used for spraying the rotary drum screen in mechanical pre-treatment and spraying the sludge screw press. And actually, like any other technical water in the treatment plant area, that means for rinsing. Hose connections are available throughout the building. The operator, wherever he needs to wash something, uses purified water. The treatment plant is therefore without the consumption of drinking water is for technical purposes. The intensified and reconstructed Horoušany treatment plant, unlike the original treatment plant, is also equipped with a sludge outlet. The sludge tailings or sludge management consists of aerobic sludge stabilization. The aerobic sludge stabilization tank is located under the machinery space, and the sludge end is formed by a slow-running screw sludge dewaterer. It is in the room adjacent to the machinery space. What we see here is actually a dewatered sludge screw conveyor, and the container into which the dewatered sludge falls. This container is then transported away by the operator and disposes the sludge from the container together with the sludge from other treatment plants. We are now in the control room, which is the brain of the entire treatment plant. The whole treatment plant control is fully automated. Any interventions by the operator or technologist take place via a large touchscreen panel, where there are screens with visualizations of the technology, list of parameters, balance and other variables that the technologists monitor. The treatment plant is also equipped with a telemetry station, which allows the transmission of all information to the operator's control room. The control system also allows remote connection from any device such as a phone, tablet or personal computer. It is a bit of an exaggeration to say that the technologist always has his treatment plant in his pocket. The membrane bioreactor technology is suitable not only for municipal wastewater, but also for wastewater from industrial plants. Thus, if you are facing insufficient capacity of an existing wastewater treatment plant or insufficient quality of treated water, membrane bioreactor technology is advantageously applicable. The treated wastewater from the membrane treatment plant is also suitable for recycling. This allows industrial companies to reduce water abstraction from sources in times of impending drought or drinking water abstraction from the public water supply. On behalf of ENVI-PUR, thank you for watching our video tour of the Horoušany wastewater treatment plant. If you have any questions about this particular treatment plant or membrane technologies in general, do not hesitate to contact us. Thank you for your attention.